Have you ever wondered about the origins of our home, the Earth? Today we'll embark on an epic journey tracing back the roots of Earth's existence. Picture this: billions of years ago, our entire solar system was but a mere cloud of dust and gas, floating aimlessly in the vast expanse of the cosmos. Then something remarkable happened. Amidst the cosmic cloud, a star was born, a fiery, radiant mass we now know as the Sun. This was a monumental event, for the birth of the Sun marked the beginning of a process that would eventually lead to the creation of Earth and its sibling planets. The Sun's gravitational pull caused the remaining dust and gas to start swirling around it. Over time, these particles began to stick together, forming larger and larger clumps. These clumps eventually grew into the planets of our solar system. Among them, one stood out, destined to become a beacon of life in the cosmic ocean. And so, from a swirling mass of cosmic dust and gas, our solar system began to take shape. But how did this cosmic dust transform into the planet we call home? Let's delve into the early stages of Earth's formation, a time of extreme conditions and pivotal transformations. In the beginning, our planet was nothing more than a fiery ball of molten rock, enveloped in extreme heat. It was a hostile and uninhabitable environment, far removed from the life-sustaining world we know today. This molten mass gradually began to cool down over a period of millions of years, forming the Earth's crust, the solid shell on which we walk today. Imagine a potter's wheel, tirelessly shaping a lump of clay into a beautiful pot. Similarly, the forces of nature worked tirelessly, shaping and reshaping the Earth's crust. This process, known as plate tectonics, played a vital role in the formation of our planet's unique landscapes. From the towering Himalayas to the deepest trenches of the Pacific, every nook and cranny of our planet has been shaped by this relentless process. But our Earth's story doesn't stop there. While it was evolving, it was also being bombarded by asteroids. Now you might think of asteroids as destructive, but in the case of Earth's formation, they played a crucial role. These celestial bodies hurtling through space brought with them essential elements and compounds. Some scientists believe that they may have even delivered vast amounts of water to our planet, contributing to the formation of our oceans. The asteroids didn't just bring water. They also brought the building blocks of life. These included complex organic molecules such as amino acids, which are the very basis of life as we know it. Thus, these impacts weren't just shaping the physical attributes of our planet, they were also seeding it with the potential for life. As these events unfolded, the stage was set for the emergence of oceans, and with them, the possibility of life. From a fiery, inhospitable rock, Earth had transformed into a water-rich, life-sustaining planet, ready to embark on its next chapter in the cosmic saga. Oceans covering most of our planet's surface, but where did all this water come from? This is a question that has intrigued scientists and enthusiasts alike for centuries. The answer, while not entirely certain, lies in a couple of fascinating theories. Firstly, let's consider the theory that water was already present on Earth, locked within its rocks. As the Earth cooled down after its fiery formation, intense heat and pressure within the planet's core caused these water-filled rocks to release their moisture. This moisture then rose to the surface, initially as steam due to the high temperatures. Over time, as the Earth's surface cooled, this steam condensed into water, eventually forming oceans. But there's another compelling theory that suggests our water might have come from outer space. Yes, you heard it right, outer space. This theory proposes that water was delivered to our planet by icy comets and asteroids. These celestial bodies, originating from the colder outer regions of our solar system, are known to contain ice. As they collided with the Earth, they melted, releasing their precious cargo of water. Over billions of years, these collisions could have contributed significantly to the vast oceans we see today. So, which theory is correct? Well, it's likely a combination of both. Recent research suggests that a good portion of Earth's water is older than the Sun, hinting at a cosmic origin. Yet the water contained within the Earth's rocks could also have played a significant role. Regardless of the source, the arrival of water was a game changer for our planet. Water is the lifeblood of our biosphere. It's a crucial ingredient for life as we know it, providing the perfect medium for complex biochemical reactions. Without water, the evolution of life on Earth might not have been possible. With the arrival of water, Earth was ready to support the emergence of life. So the next time you take a sip of water, or gaze out at the ocean, remember, you're witnessing a phenomenon that's not only vital to our existence, but also incredibly mysterious and absolutely extraordinary. Water was here. But how did life, as we know it, come to be? This question has puzzled scientists for centuries. As our understanding of the universe expands, we are getting closer to the answer. It seems that life, in its most elementary form, started as single-celled organisms in the ancient oceans of Earth. These primitive life forms were simple, yet their existence marked a pivotal point in the history of our planet. Over billions of years, these single-celled organisms gradually evolved, becoming more complex. But the real game changer came in the form of photosynthesizing bacteria. These tiny organisms, although microscopic, had an enormous impact on the world around them. Photosynthesizing bacteria are green, and they get their energy from the sun. But their most significant contribution is that they produce oxygen as a byproduct of their metabolic process. This process, known as photosynthesis, is the same one that plants use today to convert sunlight, water, and carbon dioxide into food and oxygen. When these bacteria first appeared, Earth's atmosphere was primarily composed of nitrogen and carbon dioxide, with negligible amounts of oxygen. But as these bacteria multiplied and thrived, they started pumping oxygen into the atmosphere. Over the course of around 2 billion years, this process, known as the Great Oxygenation Event, transformed Earth's atmosphere into one rich in oxygen. This oxygen-rich atmosphere was a game-changer for life on Earth. It allowed for the evolution of more complex multicellular organisms. These organisms, over countless generations, evolved into the diverse array of life forms we see today. From the smallest insects to the largest mammals, from the simplest plants to the most complex trees. In a way, we owe our existence to these tiny, photosynthesizing bacteria. They transformed the Earth's atmosphere, making it hospitable for life as we know it. This transformation of the atmosphere set the stage for the evolution of more complex life forms. From a barren rock to a thriving ecosystem, how did Earth become the planet we know today? As we trace back the steps of our planet's dynamic journey, it's fascinating to see how it has evolved over billions of years. The Earth, once a fiery ball of molten rock, slowly cooled over time, forming a hard crust. This crust, initially barren and desolate, was not meant to stay that way. With the arrival of water, possibly from asteroids, the stage was set for an extraordinary transformation. Oceans formed, creating a conducive environment for the first forms of life to emerge. Bacteria began to thrive in these oceans, and over time they developed the ability to photosynthesize. This process released oxygen into the atmosphere, transforming it into the one we know today, capable of supporting complex life forms. These life forms diversified over millions of years, leading to the creation of a myriad of ecosystems, each unique and teeming with life. The evolution of life on Earth is a tale of resilience and adaptation. From the tiniest microorganisms to the largest mammals, every living creature has played a part in shaping the Earth as we know it. This vibrant tapestry of life has been woven thread by thread, mutation by mutation, over the course of billions of years. In the grand scheme of Earth's history, the arrival of humans is a recent development. Yet in a relatively short span, we've made significant changes to the planet. We've built civilizations, harnessed the power of technology, and made remarkable strides in understanding the universe. But with these advancements come great responsibilities. As custodians of this beautiful planet, it's up to us to ensure its survival for future generations. We have the power to either preserve this intricate web of life or disrupt it, and the choice we make will define our legacy. And so, from a cloud of dust, Earth has evolved into a complex and beautiful planet teeming with life. Our journey from cosmic dust to a bustling planet is truly remarkable, isn't it? We've traveled through the vast expanse of space and time to understand our home, Earth. We've seen how our solar system originated from a cloud of dust and gas, eventually forming this habitable planet we call home. We've witnessed the birth of Earth, a fiery spectacle of extreme heat and cooling that laid the foundation for all life. We've explored the arrival of water, a crucial ingredient for life, potentially brought to Earth by asteroids. We've delved into the evolution of life from photosynthesizing bacteria to the diverse species we see today. And we've appreciated the Earth as it is now, a thriving planet teeming with life and beauty. What a journey it has been, filled with monumental transformations and miraculous events. And yet, it's a journey that continues every day, With each sunrise and sunset, each wave that crashes upon the shore, each leaf that rustles in the breeze. Next time you look up at the night sky, remember that we are all made of stardust, a part of this grand cosmic journey.